In Unit 1, Homework 8, we're going to be looking at information that has mostly to do with circles. Specifically, we'll be looking at the distance and midpoint formulas and also talking about the equation of a circle as well. So to get started, let's go ahead and put down some relevant formulas that we'll want to know. And the first one is the distance between 2 points. Now when we're talking about the distance between 2 points, we're usually referring to some ordered pairs, let's say like x1, y1, and x2, y2. And of course we know that these could be positive or negative numbers, they could have fractions or radicals involved. Well, the distance between these 2 points then is the square root of the difference in the x plus the difference in the y, and each of those individual values are squared. So the difference in the x values, quantity squared, plus the difference in the y values, quantity squared. When I add those together after I square them and take the square root, and that's my distance formula. And this just comes directly from Pythagorean's theorem. We'll also want the midpoint formula. The midpoint gives us the middle value between two ordered pairs. So the midpoint between 2 points. Now for the midpoint formula, I can go off with these same two ordered pairs, x1, y1, and x2, y2. So for the midpoint formula, a lot of times you'll see it labeled capital M, because lowercase m we kind of use for slope, so this would be more like cap M if it's labeled at all. And what you do is you add together the x values and take their average, divide by 2, add together the y values, take their average, which is the same as dividing by 2, and then these are an ordered pair, and so this would be the ordered pair 2, 1 or negative 1, 3. And so look at some values where we're having the midpoint as well. The last thing that we're going to be looking at is the standard form of the equation of a circle. Now this is important because in standard form I can immediately tell exactly what the center is of the circle and the radius. So the standard form for the equation of the circle looks like x minus h, quantity squared, plus y minus k, quantity squared equals r squared. Now the center of the circle then is the ordered pair hk. Notice it's opposite because I have a minus sign here. And the radius of the circle is just lowercase r here, radius. So these are the equations that we're going to be using today in order to work on this homework of distance, midpoint, and circles. So first of all, we all know what a circle is. We can certainly all draw a circle, but let's specifically break down a circle a little bit more. We know a circle has a center. There's only one center to a circle, and in this particular case that center is hk for this. So once I find this circle, the distance from the circle to any point on the outside of the circle is this radius r. So if I were to draw a lot of these distances and these points, what would happen is I'd eventually have all the points that made up a circle. So the set of all points in a plane that are equidistant from a fixed point from this fixed point in the middle that's your center is basically a circle. The fixed point is the center, and the distance from the center to the outside is called the radius. Now again, this center is hk. So again, it's all points that are equidistant from that center. So let's go ahead and just start working a few problems using some of these formulas that we've talked about. The first one that I want to look at is the distance. Now I'm going to go into a lot of detail on this first problem to kind of show where this formula comes from, but then after this we'll just use that formula. So let's go ahead and find the distance. And let's go between the 2 points. Let's do 3, 4, and 7, 10. Okay, so if we were to graph these points, 1, 2, 3, 4, 5, 6, 7. 3, 4 would be, let's say, right about here. So here's the ordered pair 3, 4. And then let's look at 7, 10. So here's 7, and then we go up 10. Here's our ordered pair 7, 10. I'm looking for this distance right here. This is what I'm up to today. So in order to find the distance, what we're really going to be looking at then is we're going to be creating this right triangle by looking at the horizontal and the vertical, and I have a right angle right here. And as soon as I draw this nice little right triangle, I can use Pythagorean's theorem. Well, how do I figure out what this distance is? Well, this was 7 over, this one was 3 over, and then vertically this one was 4 up, and this one was 10 up. So if I wanted to know the distance between 3 and 7, I would take 7 minus 3. If I wanted to know the distance between 10 and 4, I would take 10 minus 4. Now Pythagorean's theorem says I take the leg plus the other leg, square them both, of a right triangle, and basically leg squared plus leg squared equal this hypotenuse squared. And I'm going to call this H for hypotenuse. We're also thinking about this as D for distance. So leg squared plus leg squared equals hypotenuse squared. So what we have here, let's call this our bottom leg, is 7 minus 3. And I know you want to call this 4, but we'll develop this up here in a minute. Our other leg was 10 minus 4, and its length is squared as well, and that's hypotenuse squared. Well, I don't want to know what hypotenuse squared is, I just want to know what H is. And so what we do is you go ahead and take the square root of both sides, and I have the difference in the x's squared plus the difference in the y's squared equals H. And of course my square root is over here. So that's where my distance formula comes from. Now if we want to just work with the distance formula, I just call that D for distance, so this is the same as my distance. So I have square root 7 minus 3 is 4 squared, 10 minus 4 is 6 squared, 4 squared is 16 plus 36. Now I can't take the square root of 16 plus the square root of 36. I need to add these together first before I can take the square root, because the square root does not distribute across addition. So I'd have 16 plus 36 here, which is 52. So this is the square root of 52. Now we have to decide, would I leave my answer like this? Well, what we want to think about here is, does 52 break down? Does it have any factors that are perfect squares? So for 52, that's 4 times 13. So 13 times 4 is 52. So I can break this up into root 4, root 13. The square root of 4 is 2, so I get 2 root 13 for my distance here. And this is an exact form. I don't need to find a decimal approximation, but this is the correct solution. The square root of 52 is not simplified. I need to take it further and simplify it. So again, if you get to a number, think if there are any factors of 52 that are perfect squares. So not simply, but simplify. So we want to simplify this. Okay, so that's an example of using the distance formula. And you can use the distance formula for all sorts of kinds of ordered pairs. They could both be negative, they could both be positive. They could have square roots, they could have fractions. And so you're going to run into all sorts of these different types of problems. I'd like to look at one distance formula that involves some negative numbers, because that can get a little tricky. So let's go ahead and find the distance. And let's do between the ordered pairs, let's do -8, -5. And our other ordered pair would be, let's say, 2, -3. Now I'm not going to draw this and sketch that out in the right triangle like we did up here. I just did this picture to kind of show you where it comes from. If you want to use the Pythagorean's theorem to solve these, you're welcome to. I'm just going to go ahead and skip to the formula. So the first thing I'll do is I'll write down my formula. The difference in the x's squared plus the difference in the y's squared, and of course add those together and square root it, and that's my distance. Okay, so I could call this one x1, y1, x2, y2. So the difference in the x's, I'm going to take 2 minus, and this is where the trick comes in, 2 minus and -8. You have to have the minus and the negative. Plus, let's go ahead and look at our other one here. I still have to start with the same point, -3 minus a -5 squared. Now, truth be known, it actually doesn't matter which order we subtract them in because we square it. And so if I have a positive and square, it becomes positive. If I have a negative squared, it becomes positive as well. But it's good to keep in the same order like we do when we're working with slope, just to keep that clarity. Okay, so minus and negative is the same as a positive, so this is 2 plus 8 quantity squared. Here we have negative 3 plus 5 quantity squared. This goes all the way over here. Gotta extend that out. So 2 plus 8 is 10, so I have 10 squared. Negative 3 plus 5 is 2 squared. And again, I can't take the square root of these individually. I need to add them together first. So I have 10 squared is 100, 2 squared is 4. So I get distance is the square root of 104. Now, for this one, I want to look at perfect squares again. Are there any factors of 104 that are perfect squares? And I think 4 is definitely going to be one. So let's take 104 and divide it by 4. And we would get root 4, root 26. So I get distance is equal to 2 square roots of 26. I don't want a decimal for that. That's my exact solution. So finding the distance between points is pretty straightforward. You need to remember the formula though. Let's go ahead and look at midpoints next. So for midpoint, I might be trying to find the midpoint between two ordered pairs. So I'm trying to find the middle value. So let's go ahead and look at something like, well, let's do 2, 3, and then let's do 4, 10. So if I wanted to sketch this real quick, I could just kind of focus in on this first quadrant. So 2, 3, right here. So this is the ordered pair 2, 3. And then let's go ahead and look over here at 4, 10. All the way up to here. Here's 4, 10. And so there's a line in between here. I don't want to know the distance of the line. What I'm looking for is, where's the middle? So this is that middle point. So this is the midpoint. And I might not have sketched it in exactly. This maybe looks a little shorter over here. But we're getting at the midpoint. Where's the middle between those 2 points? And I'm looking for that ordered pair. So let's go ahead and see if we can come up with what that ordered pair is. So of course we'd write down our formula. So midpoint equals x1 plus x2 over 2. So the average of the x's are my x value, and the average of my y's are my y value. So I'd have 2 plus 4 over 2, and then I'd have 3 plus 10 over 2. So my midpoint would equal 2 plus 4 is 6 over 2 is 3, and then 3 plus 10 is 13 over 2. So this is my midpoint. So 13 halves, I'm going to leave this in fractional form. In MyMathLab, we always would prefer improper fractions over mixed numbers. Okay, and in the directions it will usually say leave it in fractional form. It won't say mixed numbers. But if I wanted to graph this, this would be 3 and 6.5. So 3, 2, 3, 4, 5, 6, 6.5. That wasn't too far off. So that was the ordered pair of 3 and 6.5 if I want to look at it in decimal form. But this is the form that I'd use for MyMathLab. So we've looked at the distance formula, the distance between 2 points, and we've also talked about the midpoint, and sometimes you're going to be working with fractions, sometimes you'll be working with radicals, and again, it doesn't matter which one you're working with, the same process still holds. Let's go ahead and talk about circles next. So a lot of times you'll say, okay, well, write the standard form of the equation of a circle. You'll be given some general problem, and in the general problem, you'll be asked to write the standard form of the equation of a circle. And usually you're given a center and a radius. So I'm just going to pop in a problem here from MyMathLab. It would be the kind of problem that you would see. So this says write the standard form of the equation of the circle with a given center and radius. Well, the standard form of the equation of a circle, if you'll remember, was x minus h quantity squared plus y minus k quantity squared equals r squared, where the center is hk and the radius is equal to r. Well, we know that our center is 0, 0 from this problem, and we know that our radius is equal to 4. So what we would write is x minus 0 quantity squared plus y minus 0 quantity squared equals 4 squared. But in MyMathLab, you'll see that it says simplify your answer. So x minus 0 is just x, so this is going to be x squared. Y minus 0 is just y, so this would be y squared. And of course, 4 squared is 16. So this is the standard form of the equation of that circle in simplified form. So if it says to simplify, you need to make sure that you are thinking about simplifying that. Now sometimes the center or the radius will be something a little bit different than you might expect. Let's go ahead and look at an example where we might have a center that has negative values and a radius that might have some radical values. So to start with, as usual, I want to go ahead and write down what is the general equation of my circle. So this is x minus h quantity squared, y minus k quantity squared equals r squared. So our center here is hk, and our radius equals r. Well, our center is -6, -4, and our radius is square root of 5. So we would say x minus a -6 quantity squared plus y minus a -4 quantity squared equals the square root of 5 quantity squared. Okay, minus and negative is the same as a positive because we need to simplify. So x plus 6 quantity squared plus y plus 4 quantity squared. And then root 5 times root 5 is root 25. The square root of 25 is 5 right back. So this is a standard form of the equation of the circle, which has a center of -6, -4, and it has a radius of 5. So again, be careful when you're writing these out. Simplify them as it says. If you have x minus 0, you can just go ahead and write that as x, and then we can kind of work from there. Now in MyMathLab, you'll also be asked to graph, and so I want to make sure that we look at a graphing problem as well. So let's go ahead and slip in MyMathLab in here. Okay, so hopefully you'll be able to see the whole window. This one says, give the center and radius of the circle described by the equation and graph the equation. Well, we can see right away that this center of this circle is 0, 0. So we grab our circle tool and go ahead and move it to the center. And then over here we can also see this value of 9. That's r squared. Well, if r squared equals 9, r is equal to 3. So I'd come back over here and I'd go out 3 units in any direction and click, and then there would be the equation of my circle. So graphing these isn't too tough. You go ahead and grab that graphing tool, and then once you have that graphing tool that's the circle, you plot the center, and then after you plot the center, you go ahead and work on the radius. So let's go ahead and paste that into the lecture as well, and then we'll talk a little bit more specifically about where we found that center value from in the radius too. It doesn't look like a circle when it's squished. It looks more like an oval, doesn't it? It's a little more circular. Okay, so again, this x squared plus y squared equal 9. We're comparing this to x minus h quantity squared plus y minus k quantity squared equals r squared. Now notice we're not subtracting anything from x, so that means my center is at 0, same thing for y. And then my r squared is equal to 9, so I take the square root of both sides and I get r equal 3. So I would use my center of 0, 0 and my radius of 3 is what we're looking at there. So another thing that will come up then about this is domain and range. So our domain are all the possible x values that we can plug in. Well, it looks like there would be no restriction whatsoever on our x values. But if you look at the picture, we can definitely see that our domain, and again, domain is horizontal, goes from -3 to +3, points included, so I have brackets here, and our range, and remember our range is vertical, goes from -3 to +3 as well. Now that's not always going to happen where the domain and the range are the same. In this case it does, but again, it's not anything that I can say there's a hard and fast rule that the domain and range of a circle is always the same, because that's not true. Again, when you're trying to work with these types of problems, it's important that you identify the center first for when you're graphing, and then once you find the center, you go ahead and work off of the radius. Let's go ahead and look at one more example from MyMathLab. And this time, let's go ahead and do the work ahead of time, and then we'll graph it based on what we found for the work. Okay, so for this one, we're going to try and find the center and the radius first, and then we'll try and graph it, and we'll put the picture up. And I think on this one we'll find the domain and range as well. So again, we have the x squared plus y minus 3 quantity squared equals 16. The standard form for the equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. Well, we can see from here when we're trying to find our center, x, there's nothing subtracted from x, so that means h must be 0. Now over here, the value of k is 3. Remember, it's always opposite of what you see here, so I see a -3, so it's the opposite. And then r squared is 16, so that means r must equal 4. So here's the center and the radius that I'll want to use here when I'm graphing. So let's go ahead and pull in MyMathLab, and again, we're going to choose the circle tool, and we'll do 0 over 3 up, because that's my center. My radius is 4, so I'll go out 4 units. 1, 2, 3, 4. And so there's my graph. Let's go ahead and copy this graph. And then we'll also talk about the domain and the range. I'll just copy up the blank one. Cover that one up. Okay, so there's a picture of my circle. Domain. Now remember, domain is horizontal and range is vertical. So our domain here looks like it goes from, here's my center, it goes out 4 units in either direction, so it goes from -4 to +4. And then my range goes down here at -1, and then it comes clear up here to 7. So -1 to 7 would be my domain and the range. So most of these are pretty straightforward to work with. You are going to get to kind of a bad problem toward the end. I think it's something like number 20. Number 21 is kind of in the wrong spot. It should have been up a little bit sooner in the problem set. But on number 20, what we're asked to do is to complete the square and write the equation in standard form. And then, once we find the center and the radius, then to graph the equation. So there's a lot to this problem. And the tough part about it is probably completing the square. So let's work through an example where we might see this. Okay, it's having problems loading here. There it is. So let's go ahead and plop this one into our notes, and then we'll worry about graphing it after we complete the square. Now, completing the square we've done before. We did that in one of our previous lessons, but it is kind of a long process, and now we have 2 variables that we have to use to complete the square. So let's go ahead and start with this x squared plus 4x, and then this y squared minus 4y. And these blanks that I have here, and I'm going to move the 73 across, the blanks that I have right here are the values that I will plug in to complete the square for the x and complete the square for the y. So what I do to find this value is I take half of 4, and then I square that. Well, what's half of 4? 2. 2 squared is 4. Then over here, to find this blank, I take half of negative 4, this linear term, and take half. And I square it. Half of negative 4 is negative 2. Negative 2 squared is 4. Now, because I have these two blanks on the left, I also have to have them on the right. So I added 4 to both sides. So over here, I have x squared plus 4x plus 4. Well, again, what was half of 4? That was 2, so that's the value that goes here. If I were to FOIL this out, I'd get x squared plus 4x plus 4. Now over here, what was half of negative 4? That was negative 2, so that goes over here. Now on the right-hand side, I have 73 plus 4 is 77, plus 4 is 81. So this is the standard form of the equation of my circle. Remember, the standard form of the equation of the circle is x plus h quantity squared plus y minus k quantity squared equals r squared. So I have a center here at negative 2, 2, because remember I do the opposite. Negative 2 is my x, positive 2 is my y, and then my radius is the square root of 81, which is 9. So this is the information that I'll use to go ahead and graph this. This is my equation in standard form. So in MyMathLab, when they ask for standard form, this is what they're looking for. So negative 2, 2 with a radius of 9. Let's go ahead and have a look. Now, we want to make sure, oops, we better put this in, because if we don't put this in, they're not going to let us get to the graphing part. So what was that? X plus 2 quantity squared plus y minus 2 quantity squared equals 81. I think that's what it was. Okay. So now we can graph it. Gave us our graphing tool. So the center is at negative 2. So I start at the origin, negative 2, positive 2. And the radius is 9. So from here I'm going to go out 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's my other point. So there's my graph. And I'll go ahead and pop this into the lecture as well. Now this one didn't ask for the domain and range, but we can include that just because it would be good information. So there's the graph. And it's just kind of squished looking because of the scale. Doesn't quite look circular. So if you wanted to check out the domain here, remember the domain is horizontal and the range is vertical. And I'm reaching those endpoints. So up here, if I check out the domain looks like it goes from negative 12 to positive 7. So negative 12 to positive 7. And the range, and again, what I did here is I went to this point and the symmetric on either side. Now the range is our vertical movement, so it looks like our range, well, this point up here, looks like it goes up to 11, and then down here to negative 7. So negative 7 to 11. So this homework is actually pretty short. You need those first 3 formulas we talked with at the beginning, but for the most part this should go pretty smooth. You need to keep track of things though. You need to keep track of your positive and negatives and whether you're talking about distance or midpoint. One completing the square here, it's not too bad. Just make sure you use the example from your notes when you're working on your homework. Good luck.